let me thank Michael and the Orlando user group for, let them me present, this talk about data binning techniques. And this was from an article that I was reading, and you can see the source there on Analytics Vidya, which is an Indian company, uh, doing training and consulting on business analytics and data science and all that. So and that intrigued me because one of the in the courses that I have taken from data science, online courses and presential talks, one of the things that it always bugged me was, why do we want to do this? Okay, in terms of converting, and I'll show you the definition. In terms of converting a continuous variable, a numeric variable, to a categorical one. And when reading this article and then digging deep a little bit on the subject, I found out that it has some useful solutions to some problems that numerical variables can entail. So first of all, a little bit about me. As shown there, my name is Ricardo. My education, I have a bachelor's in industrial engineering. I also have a master's in engineering management, and I study Juris Doctor. So maybe in another world, another life, I will be practicing law. But I decided after studying, I decided that that was not, what I was, what I was interested. But again, part of the twists of life, I have used, the law knowledge, to a certain extent. And my day job is really appraising. I do mostly now personal property appraising. I still do some jobs back in Puerto Rico, where I come from. And I'm involved also in some interesting data science projects, that I'm doing as a freelance. So let's see, what are we talking about here? And the objective of this talk is going to be exploring from that article, exploring some of the pandas techniques that you can use to accomplish this, the data binning. And what is really data binning? Well, data binning is what is called discrete binning or bucketing. And what are you trying to do in your data set, or your, it has also applications on imaging also. What you're trying to do is to reduce the effect of that numerical variable because of certain quirks that the data has. For example, maybe it has some minor observations on one end. Also, it has maybe some extreme values, okay, what is called the outliers. So this technique of, changing that, type of feature from the continuous numeric feature to the categorical is a useful one. And I have used it precisely for trying to deal with the outliers. When we talk about outliers, we talk about extreme values. Let me give you an example. For example, if you take the weights of certain, or a certain community, and then you compare it, that weight to, a group that has, that has, more weight, or something like sumo wrestlers, for example, you will see that those sumo wrestlers are kind of outside that group, and that could distort, the whole, analysis of that, particular data. So one of the things that we want to do is try to see what kind of functions, or what kind of techniques we can use in pandas to, accomplish this. So the data set that I'm using, and it's not the one that it was used in the article, I went a little bit bolder. And I wanted to, try to test different techniques in terms also of the speed, because the article talks about speeding your pre-processing stage in the data science, pipeline. So this data set is kind of it's kind of a middle-sized data set. It comes from Expedia. It's from a competition that it was done back in 2013, and it has around 10 million rows. Okay, so it's fairly fairly sized, and it will give you an idea of how much time each of these techniques you could spend. Okay, so this is kind of an image. There's another source here that I recommend also. It's called Numeric Python course, and it only talks in this website. It only talks about data binning. So they have other techniques on how to do it, but I will stick to the previous article. And what we're trying to do here is trying to put the happy faces in one bucket, put the not so happy faces, the fire ones, in the red bucket, and then put the not so, the middle ground in another bucket. So it's also a funny way, to see our problem. Okay. So I'm using, behind this is a Jupyter notebook. The Jupyter notebook is used widely, for data science projects, and it's basically a scripting with pandas within a notebook format. So the first thing that you're going to do, I'm not going to show it here, but the first thing you're going to do is that you're going to read the data set. And the data set is in a CSV, separated values. So I'm going to give you just the highlights because I want to focus on the techniques. So this data is about, like I say, it's about 10 million rows, and it has 54 columns. And this is a snippet, the heading of the data. So the feature that we're going to be seeing here is what is called the gross booking USD, which is defined in that data set, is defined as the total amount of the transaction that was done when the booking was done in the Expedia site, in the hotel booking. So we're going to use this, and as you can see right now, we have some values that are missing, right? So we're going to deal with those. Okay, so the first thing, in order to make it more, make it easier to deal with this data, what I'm going to do is I'm going to take a sample of it, and I'm going to take a sample of 40% of that data set to then illustrate, those techniques. And we're going to use a random seed. Okay, it's called random state 42, so we can reproduce, the sample, and then with the shape command, then we reduce those 10 million rows. We reduce it to around 4 million rows with the same columns. So remember that we're going to deal only with the gross booking USD in US dollars feature. And with the describe function, you can then get a glimpse of what the distribution, the ranges of that data entails. For example, they give you the counts, which is the counts that have numeric values, discounting the missing values. Then you have the value of the mean, which is the average. It was about $390, the average for those bookings. Then you have the standard deviation, and then you have these values, which are the quantiles. If you chop that data into 4 equal sections, these are the values that are going to be the thresholds, for those divisions. And we're going to use those values precisely to do the binning. Okay, so we're going to split that continuous variable. We're going to split it in 4 buckets of each, of equal size. Okay, for this data set. And as you can see, there's a maximum value, and this is, it could be probably a mistake or something, but we don't know. But there's a value of $167,000 for a booking on a hotel. Who knows? Maybe it's in, in Abu Dhabi or one of these luxury cities. Okay, so but that is part of the problem that we have, because this definitely is an outlier. If you have an average of $390 per booking, well, $160,000 is going to be a really big outlier. And I'm going to show you in some of the visualizations that we do in the exploration of the data, you're going to see, that distribution and those outliers. Okay, so remember that we had some missing values. Well, I wanted to check, how much was the percentage of missing values in the gross booking feature, and it's quite high. It's about roughly about 94, 95% of the data. So before doing the binning, we have to, get rid of those values just for academic purposes. But usually, if that feature is not useful, or is not the target, for example, to get the prediction values, probably that will be very, very troublesome, to get some information out of it. But in this case, because we have a lot of data, what we're going to do is that we're going to drop those values, and we're going to do the drop NA, okay, subsetting for that feature. And then we're going to only use the numeric values. And as you can see, again, with the heading, with the data set, now we have some values instead of the nans that they were shown before. Now we have some values, and now we can do our binning. So this is some illustrations of the exploratory analysis that usually we do for numerical features. And one of the things that we want to do is see how are the values distributed, because this feature has extreme values. One of the problems that we have is that all of these values are concentrated in a very slim range, which is around 0 to 400, 0 to 500. And because it's so slim, then you cannot see, there's outliers everywhere until this number, remember that number of maximum $160,000? Okay, so you'll see all these values where they are the frequencies is very small, so you cannot see it. And that also, impairs us, to really visualize what is going on, with those numbers. So there's another visualization here, using airbox plot, which is what is called a non-parametric visualization, which we use the median, and then we use, certain ranges like the quantiles, etc., to try to see where are the values grouped. And these diamond shapes that you see, those are outliers. So as you can see, there's a couple of them. It's not one or two. There's a couple of them that are kind of skewing this value, this distribution to the right. Okay, and that's why we want to use binning to try to get hold of that situation. Okay, so again, we want to create this new feature variable where we're going to convert that numerical feature, which is called gross booking USD, to categorical. And this is the way that we're going to do it. So method number one, what we do in Python, we write a function, right? So we're going to define a function, which is the first method, to bucket those values into certain ranges. So the first thing that we want to do is try to get those ranges. And one of the functions that you can use is called CueCut, okay? And what you do is that you insert the data frame and the feature, in this case, into that function as an argument. And then another argument after the comma is going to tell you how many buckets are you going to create. In this case, we're going to create 4 buckets, mimicking something that we saw in the describe function, where you have the 25%, the 50%, the 70%, which are the quantiles. So we're going to divide it in 4. And this, where it says categories 4, interval float 64, these are the ranges. So we're going to have a first range between 0 to somewhere around 124, rounded it. Then 124 to 19, then 219 to 431, and 431 on will be the last category. Okay, so we're going to convert it into 4 bins, 4 buckets. And this is the function, it comes from the article, I have to disclose that. This is the function that we're going to use to then, apply it to a for loop. And in this function, what you do is that you define, the name of the function, apply bins, and then the argument. Then you use the if, elif, SL structure to define your bins, and then return the category. So we're going to define this function and then apply it, using a for loop. So we have this for loop, okay? We define the cat list, which is the variable where we're going to insert those categories. Then we say for I in range of length of data underscore 2, which is the number of rows that we're going to use. We're going to then get the value from the gross bookings ID for each row and store it in this variable. It's called BNS, okay? Instead of bins, not to repeat the same name, BNS. And it's going to create like a series, right? A series of values from the gross bookings. Then we're going to apply that function that we saw in the previous slide. We're going to apply it to that variable, to that bins. And we're going to store it in something called cat, because that's the return that we're going to get, the category. Then we're going to, in the same for loop, we're going to append that category to a cat list, which is the variable that we, outside the for loop, define. And what we're going to do then, after the for loop ends, we're going to then store those categories that match the same value on the gross bookings ID, USD. We're going to store it in a new feature called bin/categories. Okay, so this is basically straightforward. This is defining a function and running a for loop, and that's it. The problem with this is that the execution time of this function is around 15 seconds. Okay, so for 4 million rows, you will say, well, 15 seconds is not that bad. But imagine if we had 100 million rows, okay, that we have to deal with that, big data, in other words. So this number could, escalate to probably minutes and even hours. So this is our first, kind of brute force. They call in the article brute force technique to, do our binning. Probably not the best, way to do it. And you'll see the other examples that you see. Okay, this is not, what we, especially in a production, stage, we want to do. But this is the, the result of this binning. So you have this values, the first 10 values, and then you see the categories of the different values. For example, if it was more than 431, it's going to show you that category. If it was less than 124, it's going to store it there, and so forth. So we have accomplished our first data binning. Can we improve it? Oh, yes, we can. So the second method that they discuss in the article is called the iter rows, and this was new to me. I didn't know this function. Okay, so it was something that it was tickle my mind. So the iter rows, what it does is that it generates in the rows of the data frame, like it says there. What it does is it returns the index of each row, and then also returns the object in the row itself. So it does both things. It returns the index, and also it returns the object containing the information on the row. So that's very convenient. So what we're going to do is apply again the same function that we defined. Remember, apply bins, the same procedure, cat list. But then in the for, we're going to use the iter rows, okay, of that whole data frame, and we're going to store it into variables, the index and the row, because that's what it's returning. But we only need the information on the row for the gross bookings USD. So we're going to do the same thing. Instead of the data.ilog that we use in the previous example, we're going to use the row and then precisely that value from that feature. We're going to store in bins, we're going to apply the function, we're going to store it in cat list, and so forth. And then we're going to create another feature so that you can compare from the output of the method number 1 of the define function to the output number 2, you'll see will be identical. And now the time that we have for execution using iter rows, it changed dramatically, right? From 15 seconds, now we have 6.82 seconds. So we are in in the right path. Okay, we are optimizing our the data binning function. Okay, so this is the result, and as you can see, they are identical. The only thing, the only aspect that I can point out is that one is much faster than the other, much efficient. Can we do better? Of course we can do better. Okay, so the next method that we're going to do is using apply. And apply, it gives is a function within pandas, and it's optimized to do this kind of thing, this kind of loops that we need to do. There's a new element here, and in the apply that you have to be aware is that there is a parameter called axis. And axis, you have to define it if you are going to apply the function to a row or if you apply the function to a column. In this case, because the gross bookings USD is a column, we're going to apply it to a column. So let's see how we do this. Okay, and one of the things that I like about the apply is that it's one-line code. Okay, you don't have to go around. You have to define the function, of course, the apply bins, but you don't have to do the for loops, you don't have to do the iter rows, etc. It's very compact, and that's good. Okay, whenever I see one-line codes doing the work, I really smile. Okay, so here we're going to use the syntax of pandas with the data frame, function apply. We're going to use the lambda function for the row, okay, because we're going to apply this function to the row, and then we're going to apply the bins and use the row for the gross bookings USD. In other words, it's returning from the rows that value, and then it's going to do the apply bins for that value to get the category. Okay, and of course you have to mention which method are you going to use, if you're going to use row in axis or you're going to use column. This time we're going to use columns. And as you can see, the improvement is dramatic. Okay, now we're not in seconds, we're in milliseconds. So now the average execution time for this function is 909 milliseconds. That's great in any in any aspect that we can do this. So let's see if the function returned what we wanted. Yep, it returned what we wanted. Everything is the same as we started. Okay, the only thing that we are improving our speed in terms of pre-processing these values to create that category. Okay, so can we improve this? The answer is yes. We can do one more thing to improve it. And this one is really, a charm. And is, in terms of data binning, this is the method that you should use, okay? I mean, you can use the apply, but I would recommend to use this method, which is the cut method, the cut function. And the cut function is specifically engineered, specifically created to do this, to do binning, data binning. So let's see how we're going to deal with this. So in the cut, what we're going to do is that we're going to change the type of the data frame. I'm going to change it into a NumPy array. Why do we do this? Speed. That's the reason why we're doing it. And in general, working with pandas, working with in the data science field, one of the things that you can do to optimize your code is trying to see how much NumPy you can use to optimize your code, because it's faster. Okay, and of course NumPy is the engine underneath the pandas functions. So we're going to use the cut. We're going to convert that data frame, just using that feature to an array. Then we're going to spell out the binning thresholds, okay, the binning limits again, which is 0, 124, 219, 431, and also we're going to say, to generalize, the function, we're going to choose, instead of that number 167,000 that we did with the describe, what we're going to do is we're going to get the maximum value of that array, okay, for our last, our last bucket. And we're going to label it. We're going to label it less than 124. As you can see, we're not using the function anymore here because CueCut already has the parameters built in to to get the meaning function. So we are not using apply bins anymore here. So we get the labels that we choose, etc., and then we run it, and voila, we got an execution time of 2.91 milliseconds. Okay, and that's the fastest that you can do this, and it's really a big improvement from where we started from 15 seconds back in the function number 1. And to validate our results, these are the results, and as you can see, the results are always the same. So we're doing different methodologies arriving to the same, to the same end. But this CueCut function really is the way to go to bin your data. So to give you the last, the conclusion of this talk, you can see in this bar chart how they compare, each of the methods compare with the execution time. As you can see, method number 1 is the laggard, okay, is basically around 15 seconds for 4 million rows. Then we get the iter rows, we get the apply, and then we get the bin cat, which is the cut function applied to the categories. And you don't see, even a bar there, okay, because the value is so small in the execution that is, is almost negligible. Okay, so that's what I have for data binning. How do you like it?
Well, it's fantastic.
Right? Let me tell you, like I said, when I started, dealing with data science, I knew about statistics, a long time ago because of my industrial engineering background. But when the structure said about, converting numerical variables to category variables, I said, well, why do you want to do that? I like numerical variables. Okay, they're easy to, to handle. They give you, a lot of statistics, etc., instead of categorical. But when you are confronted with a certain bad behave data, okay, then you have to think about using these techniques, okay. And now we can model gross bookings, okay, as a target or also as a feature now without the effect, the distortion effect of those outliers, okay.
And if you make the bins really small, you basically get a frequency distribution, right? A histogram.
Correct. Yes.
It's
yes.
also
In fact, I was going to add, very good, Jerry. I was going to add, but I didn't want to, extend, too long the talk. But I've seen using decision trees, for example, to get more natural binning instead of the ones that we're using, instead of the quantiles. You can process, with a shallow decision tree, but that will be, the material for another talk. But you can do a shallow with a depth of 2, basically. You can do a binning of the variables there, and then get, the threshold, the buckets, the bucket ranges. But yeah, it's part of the creativity of data science. To check, if this bucket can do, a better job than other buckets. You can play with it and see, what is the effect of adding more buckets or reducing the buckets. But let me tell you, it's a nifty way. It's a very, creative way to deal with those pesky outliers. Because if you don't use these techniques, then, or you transform the variable, right? You log it, for example, you can do that. But then, there's still a question, but what is the effect of those outliers? If you're using a regression, for example, what is the effect of that maximum value? Is it distorting my my regression line? Is it pulling it from one, from one side, etc.? So one of the things to try to mitigate this, is this technique. And very useful and very straightforward if you use CueCut.
That's great, Ricardo. I mean, that was really, I'm amazed at how much it sped up. I wouldn't have predicted that.
Oh yeah, I was too, In fact, the first time I run it, I ran it with the whole data set. I had to shut it down. It took about, before I shut it down, it took about 20 minutes. Okay, with the first function, with the function, for loop. And I said, no, this is bad. And then, I took a sample and then tried to, play with it. But let me tell you, the CueCut one is, that's the way to go. That definitively, that's the way to go.
Just looking at the response times and how they were implemented, there's a very strong correlation to just how much of the implementation of the runtime to create this is controlled by Python, with Python having more overhead. And then as you go down the graph, more and more is being processed by the pure C runtime that pandas and NumPy leverage.
Python. That's correct. Yes. Let me tell you, one of the I bet you have also. I have an account in Pinterest. The most saved, from my site, the most saved image that I have is a NumPy. It's a NumPy conversion. Okay, to illustrate, what is the execution time with this function in Python, and then what is the execution time with an array using NumPy. And that's the most saved. Every time someone is is saving it. And it's a short image, it's just a couple of instructions, etc. But there's an awareness that, hey, we found something that we can really speed up our execution time. And from production, development, this is critical. You don't want people just staring at the screen, just trying to get the prediction or value. Yeah.
Well, you get the best of both worlds. You get the syntactic sugar of Python, which is much easier to write and understand, and you get the performance of your C++, which, as you know, is agonizingly painful to produce, which runs really fast. So it's nice.
Yep.
Could you go back a slide to the CueCut call?
Yeah.
A couple slides.
Yeah, right
there.
It
is. When I'm looking at this, I'm seeing the magic numbers and magic labels in here. I'm going, if I wanted to abstract this in some way, I'm looking at the bins and the labels, going, this looks like a perfect candidate to put in a dictionary, where you can have a labels dictionary where your keys are the strings that you have in your labels there, and then the value is your bin cutoffs. So they're very clearly, they're right next to each other. And then that also means you could have them stored elsewhere, like in a JSON file that you could read in a production pipeline.
Correct. Yes.
That's very nice.
Yeah. But I'll tell you, like Jerry said, I was really amazed about the improvement of that function with the NumPy array. I mean, I said, wow, this is surprising.
I saw where you were going, whereas, okay, he's going to get to apply at some point, and then
right.
That's amazing.
Yep. And let me tell you, if I was doing it, without, reading the article or anything, I would have gone apply. And apply is decent. I mean, it's decent. It's not that bad. Okay. It's not that bad. But definitely CueCut, is the king. Yeah.
That's a fantastic reduction in time.
Oh yeah.
For a similar pre-processing technique, have you found something similarly powerful for one-hot encoding as a different type of pre-processing bidding technique?
That's interesting that you're mentioning, because I had a problem recently. It was about, I'm writing an article, that is going to be published in the Analysis Vidya, medium site, and I had the problem that in low frequencies features, for example, when you one hot encode, apart from the from the pre-processing optimization, you have a problem that sometimes when you split the data between the train and the test, if there's a category with very low frequencies, it tends to go to one place, okay, and then it kind of disappears. For example, in the test data set. So one of the things that I've been researching is that instead of using one-hot encoding, I'm using more label encoding, okay? Label encoding, and also there's others techniques that you can use, hash encoding, etc. I mean, one-hot encoding, the good thing about one-hot encoding is that, it's kind of simple, right? You divide your categories into columns and then 1 zeros and all that. And it's simple, but it creates a little bit of problems, especially when you have certain categories that are low frequency, for example. I've had that problem. But in terms of performance, I have to dig in a little bit and check, if there's ways, to try to optimize that. But what I'm saying is that I'm trying to stay a little bit away from one-hot encoding. And let me tell you, there's an article that I was reading, way back about 2 months ago about that, about different techniques on encoding a category of variable. And one of the things that he said, try not to, rely too much on one-hot encoding. Use more label encoding, use more, there's another mean encoding and all that it creates, because remember that one-hot encoding, it really explodes the number of features. If you have, let's say you have 1,000 features, and you have certain features that have a lot of, categories of cardinality, and I mean, you're going to explode that data set, and it's not, it's not the best choice to do it. But I can check. I mean, hey, I have I like to explore those kind of situations. Okay, but there are other techniques that I can tell you, and in that one I had to change my approach. Instead of one encoding, use the label encoding, and then avoid that problem of having one column migrate to the train set and then leave that column away from the test. Yeah, it happened. And when I run the modeling, for example, the linear regression or something, it was giving me errors because there was one column missing. Yep.
There's another similar function, Python function called map, which is similar to apply. Can we use a map here instead of apply? I'm not very sure.
I think you could, yeah. Yeah. You could, because map, what it's going to do is apply, right? Apply a function to a certain, a certain vector or a certain, yeah. I mean, I don't see why not. I haven't tested it, but I don't see why not. You could use a map, but try to compare. If you do it, try to compare with the cut. It's going to be difficult to beat that one, the cut function, at least for this particular situation.
Have you had any experience with, there's a pandas plugin replacement called VAEX, VAEX, that is pretty fast on data, large amounts of data, that it's not quite plug compatible. It's pretty close to doing pandas functions. And their demo data set is like 1 billion rows. And it's pretty
Wow.
interesting.
That's good. That's good. I have a research moding also for not for big data, but more for multiprocessing. There's a there's a library called modin, MODIN, and it speeds up. At least the pandas engine, it speeds up. But if you can put the link in the chat, I will check it out.
Will do.
Sure. And let me tell you, the way that we are going, especially in data science, big data is a must. I mean, you start with the traditional data sets, empty cars, the iris, whatever. But when you go, to the real world, yeah, big data is the key to many doors. Many doors here. Yep.
All right. Thank you, Ricardo. That was a fantastic talk.
Thank you.
Virtual claps all around.
Yeah.